Okay, welcome everyone to our professional learning on Unit 5 of the physics curriculum. That is orbits and field forces, and we will get right into it. So, my name is Jake Ecker. We know Kia is our science educational specialist, and she knows everything. So if you all have any questions, I'll show both her and my emails at the end of this. And move ahead. Recorded, obviously. Let's get into what we're here to do. So the next 2 minutes, I'm just going to briefly go over what is in this unit and the scope and sequence. For those of you who have taught this, you may want to skip it, but it's just going to be a 2-minute sort of quick review of what's in the unit, and then a possible sort of segmenting or breakup of this unit and what we need to cover. So this is straight from our SharePoint, and it is the lesson sequence. So you can see we start off gravity for a couple days, then getting into universal gravitation, circular motion, and then doing some application, in this case when pigs fly problems. I'll show some other examples of some problems that we can solve with these gravitation and then later electrostatics laws. Then we get into circular motion, magnetic fields, electric charges, electric force, and then sort of getting back into fields with electric fields and then gravitational fields. Then we talk orbits and comparing electrical and gravitational forces, and then sort of energy, a brief segue into energy before getting into Kepler's laws. And this simulation, if any of you have not used the simulation that they have linked here, is very, very good. I've tried to find other possibilities for simulations that could help supplement, but it's hard for me to find anything that's better than the simulation that's already linked here, sweeping out the different areas in Kepler's laws and all of those things. So those are that's an incredibly brief review of everything that's in the unit. And the way that I kind of think about or conceptualize the groups in this unit is there are about 6 lessons that are very focused on forces, field forces, action at a distance forces. 1, 2, and 3 are gravitational force lessons. 9 and 10 are very focused on electrical forces, and then 14 is the comparison between the two. So the key that I have here is just to show the approximate focus of each of these. And then for fields, we get into that in the middle of the unit, with 7 and 8 it's focused on magnetism. 11 is electrical fields, 12 gravitational, and then 15 sort of a broad view of fields. Then circular motion and Kepler's laws at the end, and those Kepler's laws are obviously more focused on gravitational than electrical forces. So that is very briefly what is in this unit. Now, normally we would see what issues we have, identify our challenges so that we can then work collaboratively on some solutions. But since this is a recording, I'm going to offer some ideas for ways that I've solved some of the challenges that I have during this unit. And so some of those are here. So the first one that I want to talk about is actually kind of for the latest lesson on paper, although I wanted to talk about this solution or supplement to the unit first, because I do use this as somewhat of a unit grounding phenomenon, that as we go through the curriculum, we keep returning to this phenomena and developing our model for it. So I will show the exact slides that I use for this introduction of the phenomena, which has also the video in it. And these slides are all posted within the folder in Google Drive, where all of the resources for this will be. So I call this phenomenon flying sugar. And we watch the video. First watch, we're just observing. Second watch, then students record their observations in their notebooks. And here's what the video looks like. And my students, we watch this probably 100 times throughout the unit, and they get very tired of it by the end. But the first time you see it, it's somewhat interesting. And it's just a quick static electricity experiment, or demonstration, really. Okay, so there at the end you can see the sugar start flying up. I'm not sure how well that will come across in this recording, but a sort of classic electrostatics experiment where you rub the Tupperware, charging the plastic, bring it close enough to the sugar so that the electrostatic force overcomes the gravitational force keeping the sugar on top of this glass bowl beneath it. And so my proposal for that as a lesson 14 supplement is based on the idea that lesson 14, or the fact that lesson 14 is all about this like sort of competition or comparison and contrasting of electrical and gravitational attractions, and this being like a pretty direct competition between the gravitational force keeping it down and the electrical force that could bring up the sugar. So then I would have students record their observations before we've even really talked necessarily or reviewed anything as a class. Then we would watch again, try to start explaining some things, record some observations, sharing with their group, adding things to their list of observations, and then trying to basically go up with like almost questions. So this is like same way that our first unit has the like question board at the beginning, trying to develop a question board for the beginning of this unit too. And then going through small group and then class-wide generation of discussions. And again, the nice thing about this is that it's like a tactile thing, and I'll show a way that we sort of test this, because students, after they see that video, usually are very interested and curious in trying out this demonstration for themselves and seeing if that it's actually work, or if there's any kind of like video magic or something, and they'll usually be skeptical for healthy reasons, and have a healthy cynicism about this. So when they want to try this, at least this example is something that they can do reasonably easily in a classroom with not very many like complicated materials, and I'll show how we've done that in just a second. But that's the thinking behind just providing something that's hands-on, that students can sort of like keep coming back to throughout this unit, thinking about forces and fields. The limitation of this is that it obviously doesn't have any connection to orbits, but I do find it helpful at least to ground the gravitational and electrostatic force discussions and explorations throughout the unit. Okay, so some of the ways that we develop that to like sort of, again, get that hands-on experience to investigate charge and charging methods is we do essentially the same thing as what's done in the video, but with little bits of paper. And so here are the slides, and again, these slides that I'll show, there aren't very many slides for this one, but these slides are all posted in the folder in Google Drive. So we use paper because I don't want mice or cockroaches in my classroom, so we use little scraps of paper that I just cut up before the day starts, and then we have these little PVC pipes that I'll show in a second. And the goal for students is to like use that and like some paper towels or something basic to get paper to, quote unquote fly, and then try to come up with their like method or their explanation for how they did it. And then we share out and we talk about what was important and what was necessary, and all of those things. So what this could look like, and you can see some other examples in here with the PVC pipe. Our school had just a bunch of long PVC pipes that we had to cut up with just like a handsaw, and then we just taped like soda cans and seltzer cans to these cups. But these are the materials. I show this to sort of show some of the later like one later exploration that we do about charging methods. But these same like basic materials, you can see the like classic school paper towel, the brown paper towels that we have like in our bathrooms and stuff. That's what we use along with these PVC pipes that we just found in our building to charge the PVC pipe, and eventually get like paper, little scraps of paper to fly up to the PVC pipe, just like it did in that flying sugar video. And we also test it with like a glass Erlenmeyer flask, because we want students to understand that things don't have to just be charged negatively to attract something, they can be charged positively too, which is a common misconception that we were finding. And the exploration that goes along with this also, which is posted or like in the folder in Google Drive, we look at like charging by friction after rubbing the PVC. What charge does it have? Why is it making the paper fly? All these different things. So they try to investigate this, and then like how do we know what becomes positive? All of these different things. But this investigation is linked in there, And again, it's going back to this constant like competition between these two field forces and thinking about the relative strengths and uniqueness of each of them. So here are a couple of the other videos that we've shown to students just to get them thinking in other ways about electric force and field forces to like, sort of prove or reinforce that these exist, because it's sometimes hard unless we can like feel some of these field forces or see these field forces to believe that they are real. So here's one on just polarization where we've charged the PVC pipe and then are bringing it close to a seltzer can or soda can with tinsel on the end. So here's what this lab looked like, or demonstration. And of course you can see the tinsel rising as the PVC pipe gets closer, and then it falls back down when the PVC pipe is brought farther away. And so we talk about electrons being pushed through this conducting can as a result of this negatively charged PVC pipe. And then, since there are an excess of electrons on one side of the can, and also an excess of electrons in the tinsel, these like locally negatively charged objects, again, locally negatively charged, will repel each other, and that's why the tinsel rises. So we talk about this repulsive electric field force that's causing this to happen. Then we look at the ways that an object can actually get charged through the same method. So we'll look at an induction lab, but ultimately it's the same idea, just a slightly different method, different charging process. So again, you can see the tinsel rising. And then now that the can is separated, while it is actually negatively charged, not just locally negatively charged, the tinsel stays risen, and then it will be touched and grounded, and the tinsel goes down. And students have fun with these labs. They'll have some big aha moments. And then this last one will be conduction, where you'll see the teacher in the video, Mr. Eaton, will charge the can. He's pushing the electrons out of the can and into his own hand. So now the can is positively charged. And then it is touched to the other can. Electrons flow into the other positively charged one. And then it's grounded and the tinsel falls. So again, all just tangible, tactile, and also like pretty relatively simple materials way to like show and visualize and make tangible these somewhat abstract ideas of like electric forces, because students have a pretty good idea of gravity, but we've found that electrical force is like sometimes hard to really discuss or understand without some of these more hands-on methods. Okay, so the other two like solutions that I've come up with to some struggles that I've had teaching this unit in the past are templates for student data collection, because there are a couple different labs, both for universal gravitation and Coulomb's law, where we're depending on students to collect data from a PhET simulation. There are the two different PhET simulations that they use, and sometimes it can be complicated, especially if you haven't done too many like quantitative labs like this before, to have a template that then students can sort of build and make their own versions of in the future. So I'll show this, and I'll show also how I've made some of these things. And so for Coulomb's law, I have a spreadsheet that just looks like this. There's a space to write their group members' names. And then the rest of this, you'll notice I color-coded things to hopefully make it as clear as possible to students, although they find ways sometimes to miss things, but that's a different story. But here we have their constants that they need to set, and for context, this goes along with an investigation that looks like this, which is also in our Google Drive folder. And like students do a really good job, I would say, of like figuring out like if we have our papers and our assignments organized, they'll navigate pretty well between these like different links and things. But there's this PhET simulation that probably many of us have used before, and if you haven't, this is like very helpful for Coulomb's law. But it's just sort of a step-by-step guide for like measuring these electric forces and observing the effect that both distance and charge can have on electric force. And so we start out, or I wanted to start out in this lab just like observing, so without recording any data. Students are just like trying some stuff, moving things around, changing charges, and then the goal would be to come up with the two main factors that affect force in this simulation. And of course, many of them, clever as they are, will look down and see like, oh, distance and charge as the things that are identified later in this, but they'll probably figure that out pretty quickly, even just by playing around in the simulation. And then so the rest of this is just like sort of a step-by-step walkthrough of like the scientific method. What's your independent variable, dependent variable, thinking about how we know that, hypothesis, now going back into this Google Sheet and setting their constants. And so for these two different experiments, both force versus charge and force versus distance, there are obviously the corresponding constants. In force versus distance, they have to keep both charges constant. In force versus one charge, we want them to keep one of the two charges constant and keep the distance constant. And I guess the most important things that I've found to be helpful during this is like I said before, like the color coding, just so that they can tell what direction goes with what. And the way that you can insert this or like make these for yourself in any lab that you want to do throughout the year, these boxes are put in here through drawings. So if you click on the insert button here and click drawing, then you can put in these text boxes and type in whatever you want it to say. And then you just want to make sure that you make it the color of whatever thing you're trying to do. And I'll usually put a border around it just because I think it looks nice. And then you can always put an arrow around it or whatever, but you would want this to match with whatever part of the spreadsheet that you go into, because honestly, like spreadsheets, especially if students haven't like used them too much before, if previous science classes or whatever, like if they haven't needed to use Google Sheets specifically, it can be for sure intimidating. So having as clear directions as possible is definitely a huge help. And then the directions here go for their independent variable, and then just sort of telling them like, or like trying to make clear what this table is supposed to do, what we're supposed to do to fill it in. And then at the end, again, depending on students' backgrounds, with Google Sheets specifically, they might not know the buttons to press. So just some instructions on like, we need to highlight our table, click insert, and chart to make sure that they get a nice pretty graph at the end. So that is one thing that I've found to be very helpful, and I do the same thing essentially for gravitational force, except whichever one of these you do first, and honestly, if you do this for earlier labs in the beginning of the year, you probably won't have to make some of these things. Like once students get some experience and comfortability with Google Sheets, we probably won't need this, or can slowly release that responsibility to our kids. But I do the same kind of thing for universal gravitation, and whichever one you do first, students will probably get a really good feel and high level of comfortability with the second one of whichever of those laws you do. Okay. Now, the last thing that I wanted to mention is a sort of like philosophical discussion, and I'll talk also about how I like to moderate class discussions. So this last kind of like solution that I've come up with to help my practice is a little bit of philosophy. So when we talk about fields, I find it like pretty abstract, like pretty conceptual and like heady. So I wanted to make this comparison to like the old philosophical discussion. I'm sorry if I'm butchering it for any of you who know philosophy better than I do, which is probably many of you. But if a tree falls in the woods and no one is around to hear it, doesn't make a sound. And so the idea here, the connection that I try to get at and explain to my students, and like they honestly like figure it out on their own. But the idea that like independent of our perception of a sound can still occur, which is kind of like the way that a field, independent of something else being around to experience a force, a field still exists, right? It's like a change in the space around an object, even if nothing is there to experience an electric force, or even if another mass isn't nearby to experience or notice a gravitational force. So that's the connection that I'm trying to get at, is that the sound is like the field, the thing that happens whether or not we're there to notice it or experience it, and the experience of hearing something, that's like the force that we may experience or notice or feel. Now you'll notice that there's a little thing that's worth explaining and maybe going over for any of you who are interested in trying a different way to do classroom discussions, and I'm still like kind of always modifying and working on this, and depending on the class or the students, like this changes and they sort of make it their own. But I do class discussions in this way called a hot take, and I'll show my procedure for that here. So I'll show whatever the hot take is up here, and we do it as like a classroom routine, so students can come up with their own like to practice, so that when we get to scientific discussions like this, it goes a little smoother. But this is really just like a protocol or a routine for full class discussions. So basically, it always starts off with someone giving some opinion. If it's like a free, like everyday, just like routine one, they can do it about anything. It definitely doesn't have to be about science, but for this one, it would obviously be about this specific question. So someone would give an opinion, a student gives an opinion, and then they start moderating the class discussion themselves. So like once students have practiced hot takes and like have gotten good at it, then I pretty much like sit back and they do their own thing. And the main focus of like this as a routine or a procedure is that I wanted to give or I wanted students to have something to do when they're listening to show that they're actively listening, because like, you know, having a classroom discussion with 30 students in a room, 30 teenagers in a room can be difficult because they all like have strong opinions, which is amazing. But if we're not like organized about that, obviously it can get out of hand, and it can get to a point where like no one's listening to each other or things like that. So the whole point of this like hot takes procedure or routine is for students to have ways to like channel their energy positively to like reinforcing this idea of like active listening and like really like not cutting off and like really trying to build on each other's ideas rather than speaking over or just to a certain like a small section of class. So when someone's speaking, like when someone else is giving their opinion on the hot take, there are a bunch of ways that you can show that you agree, and this list of things that students can do when they agree or disagree has grown over the years based on what students want to do or whatever, like what comfortability they have in expressing these certain things. So some students, like I started out, they can go they can snap, they can nod. If they don't like feel comfortable like making that much noise, they can put up a 1. If they really agree with something, they can clap. I won't say this word, but students can say these words without it being problematic. So that has been added, and you can add all kinds of things for your students to say, like to show that they are actively listening, to show that they agree, or on the disagree side, if they disagree, they can go they can shake their head, they can put up a 2, and obviously that list can grow. But again, the entire point is that students have things to do without cutting someone off, to show that they either agree or disagree, to show that they are closely and actively listening. And I found this really helpful when we want to have like more complex discussions, especially about like heady things that are hard to like make tangible or make tactile, to have something like this to moderate a class discussion and still make it like interesting and student-led, and also just like reflective of how they want to have this discussion. Obviously I did not put a period and per in here, but like students did, and they'll make it their own, and it may be different again in every single class, or from year to year for sure. But those are my ideas for some things that we could do to help like strengthen or scaffold or supplement the unit, this Unit 5 on fields and orbits. This is Kia's email, and she knows everything and is the point person for us high school science folks. And this is my email if any of you have questions about like any of the resources that I'm like sort of offering here, or anything that's in that Google Drive folder. Again, all the things that I showed here are in that Google Drive folder that we should have access to, I hope. And that Google Drive folder is in the same place that the other previous unit PDs have been at. So if any of you are trying to go back and see the Unit 1 or Unit 3 resources or anything like that, it's all within the same like big folder for the unit, and this one, all these resources are in the Unit 5 folder. So thank you guys.